In this video, we're going to cover transformations and sketching of rational functions. Before we can get into the transformations of those rational functions, we're going to have to look at two basic rational functions that appear regularly. The first one is f of x equals 1 over x, and the second one is f of x equals to 1 over x squared. The f of x equals 1 over x looks like this, such that it has two very clear asymptotes. It's got a vertical and a horizontal asymptote. The positive x values will end up resulting in positive y values, and the negative x values will result in negative y values. So in this case, we're looking at a function that looks like this. However, when looking at the 1 over x squared function, that function still has those same two asymptotes, the horizontal one and the vertical one. But the only difference is now is that when I plug in positive x values, I still get positive x values, but when I plug in negative x values, I get positive y values again. Sorry, y values. So this is what f of x equals 1 over x squared looks like. This is what f of x equals 1 over x looks like. You can try and make some generalizations about if this was cubed or to the fourth and so on and so forth. It would do very much similar patterns, such that it would look like this as 1 over x to the third, and it would look like this again as 1 over x to the fourth. It would just be steeper, more rigid in terms of it approaching those asymptotes faster. So with these two graphs identified and the way that they look, we can then build the transformation rules around these two functions. So let's go ahead and identify one more time the basic transformation rules for, say, a quadratic function. Something like this, again, will allow us to identify very clearly that we're going to have a shift up by k units, a shift to the right h units, and then this would be your stretch factor or your reflection factor. So that a value will again be a whole number, will force it to be stretched. If it was a fraction, it would be compressed, and if it was negative, it would be flipped over the y-axis. With all that being said, you can transition the comparison of this such that you have a times 1 over x minus h, like that, plus k. You'll notice that if I simplify this function, the a can actually just move to the numerator in top, and this is the transformation rules that we're going to end up applying. And notice how the same rules still apply. You're going to go up a certain number of k units, you're going to go to the right h units, and then that will be your stretch, compress, and your reflection factor. So with all that being said, if we look at a function that looks like this, y equals 1 over x plus 2 minus 1, then we can say that, hey, there's going to be a vertical and a horizontal asymptote, and because it's a singular power of x, it should look like this function here. It's going to be shifted down 1 unit. So the center point of this graph is the intersection of those two asymptotes. So my center of information, my intersection of those asymptotes, will be shifted down 1 unit, and it will be shifted to the left too, because remember, the plus 2 makes you think you're going to go to the right, but since it's on the inside of the rational function, it's actually going to go to the left. So I'm going to go 2 units to the left, 1 unit to the right, and I'm going to draw those asymptotes. So notice how this is different than how we would normally identify vertical and horizontal asymptotes, but this still does apply, and it works for all basic functions we could look at that appear, again, in this form up here. So with that being said, because of the way that this function is listed and because there's no negative factor on top, we can say that this function should look like this, such that, again, it approaches the asymptotes and appears like that. So that's how your basic function should look in terms of transformations with rational functions. If we look at one more that's just a little bit more complicated, something along the lines of this, I look at 1 over, and we'll do x minus 3 quantity squared with a negative 2 on top, plus 4. So this function here will be shifted up 4 units. It's going to be stretched by a factor of 2, and it's going to be reflected. But then this factor down here in the denominator, x minus 3, will be my vertical asymptote, such that it's going to look more like this function rather than it looks like this function because of that power of 2. So in here, I'm going to go ahead and shift it up 4 units, 1, 2, 3, 4. I'm going to shift it to the right 3 units, 1, 2, 3. I'm going to go ahead and find that intersection point between those two values. That's going to be where my asymptotes land. Right there and right there, making sure that they're dotted lines. Then normally, again, the idea is that this -2, if it was a 1, you would see the graph coming down on both top and bottom, but because it's a -2, it should look something like this. And the only thing that we have to identify clearly is that the 2 emphasize that these should be slightly steeper than what it would normally be. So we might want to just have something that looks like this to emphasize that it's been stretched again. And when we stretch it again, it's pulling it closer to the asymptotes in that sense. So that's how we're going to graph rational functions in terms of their sketching transformations, making sure that we again recognize this particular function, and anytime we see something like that, we can hopefully bypass a lot of the graphing rules that we'll have to learn in another video to easily or simply and quickly sketch a function.